Welcome to the second video of the third section. In the previous video, we introduced WebDriver and discussed its benefits. Now, let's get our hands dirty and actually implement something in this video. The question is, of course, what should we implement that is small to begin with and is still valuable? Let us verify that we can navigate to the WebDriver documentation and verify that we have arrived at the correct page. This means what we need to do is go to www.seleniumhq.org. Click on the documentation link. Then click on Selenium WebDriver link. The last thing we do is to verify the page title that is expected, which is the title of the WebDriver documentation. Before implementing this example, I have prepared a Maven project that will help us run this example from a command line. Another great thing with using a Maven project file is that we can use our IDE. I prefer IntelliJ IDEA to open the POM project object model, and we will get a project where all dependencies we need have already been prepared. Notice that we don't need to import the project file. We just need to open it. IntelliJ IDEA and Maven integrate very nicely with each other. Our first code implementation is the Java class file, WebDriver documentation test _01 Java. Unfortunately, this is a poor example because all the concepts are mixed up. Location of web elements, navigation, and verification are different things, and they are mixed up here. This mixing is bad because it will be unnecessarily difficult to maintain this test. But bad or not, this is the way a lot of Selenium tests look like. The good thing is that it's possible to clean up. Let me introduce you to some abstractions, so we can make a difference between navigation and validation. We have extracted navigation method in WebDriver documentation test _02.java file. There are two methods. One is for navigation and the other is for validation. Now is the time to do some more refactoring. Let us take a look at the methods we extracted earlier to the new classes. These classes are seleniumhq.java, documentation.java, WebDriver documentation.java. These are all available for page navigation. And the test class WebDriver documentation test _03 Java, which is responsible for performing the verification of assertion. As the single responsibility principle says, that every context, class or function should have a single responsibility, and that responsibility should be entirely encapsulated by the context. In other words, do one and only one thing. In this case, do navigation and only navigation. These new classes are examples of page objects, a page object that is responsible for navigation and interaction with the web pages. We will discuss page options in more detail at a later time. We didn't really gain anything in terms of less lines of code in the test, unless we chain the methods and invoke the next step on the return value. Let's see how it works. Selenium HQ file transits to HQ homepage and returns the documentation page, and the documentation file returns the WebDriver documentation page. Finally, in WebDriver documentation test _03, we have changed some methods of page objects and performed the assertion. This is the chain of these objects' methods, and we have done assertion here. A little and final refactoring on WebDriver documentation _04 test. There is a problem that we want to address before we move on. Firefox will not be stopped if the test fails. JUnit works by sending exceptions, and if we have any problem with the navigation, or if the assertion fails, we will end up with orphaned browsers. These browsers will have to be killed manually, which is a bad thing. We will address this by implementing one method that will always be executed before a test, and another method that will always be executed after a test. The @before method will always be executed before each test. The method containing @before, the JUnit annotation, will always be executed before each test. The method having the JUnit annotation @after will be executed after each test, even if the test fails. This is exactly what we want. No matter what the result is, we want to quit the browser. Focus on the name of file WebDriver documentation _04 test. It has a suffix test because Maven will execute those files which has the suffix test. Let's run this example so we can ensure that it still works. Shift plus right mouse click on project folder. Select Open Command Window here from the context menu and execute the Maven command mvn clean test. Build successful. So it passed. I wonder if this was pure luck. Let's check that. Let's change the expected page title to something incorrect. Open the file WebDriver documentation _04 test. And let's change the page title from Selenium WebDriver - Selenium documentation to Mastering Selenium Testing Tools. Let's save and run again. Now let's go to the command prompt and execute the Maven command again. Build failure, which means it didn't pass. This is enough for us to know that the assertion executed works, as it initially passed and after modifying the title it has failed. Please revert and assert the correct title. One of my colleagues recently said, "I was very careful running things often with just small changes between each run." However, I'm not sure if that is being careful or just playing it safe. I think I prefer the latter, playing it safe. I don't like it when I break things, and I want to know that when I break something, it should be easy to understand why. In a perfect world, there would only be one thing that could be broken when a test breaks. However, in reality, that might not be the case. The best way to go about it is to make small changes and run it. You can corner in on the issue and fix it well in this manner. All we had to do was create this small Maven POM. We need a few things to build this example, however nothing from Java. We need the Selenium libraries and JUnit. These dependencies are easy to specify in a Maven POM. Maven will download the missing dependencies if they haven't been downloaded from the central repository, and we will be able to use them. You might feel that Maven downloads half of the internet for the first time you use it. However, the dependency handling that Maven offers out of the box is very handy in examples like this. In this video, we have implemented our first example using Selenium WebDriver. Join me in the next video where we will delve deeper into the capabilities of WebDriver.